Okay, so here is our review guide for the test. I'll try and run through this pretty quickly. Here we've got describe the transformation of this absolute value function. That's our parent. If a 3 is added inside the function and a 4 is subtracted outside the function. Remember early on, this is f of like x minus h is the variable we used, and plus k out here. So we can see h would be a negative 3. Negative, and a negative 3 would make a positive 3 here. So that negative 3 means it's going to shift to the left by 3 units. We also said, hey, just do the opposite of what this sign is. X plus 3, it's moving left 3. So this would be a translation. Left 3 units. And then on the outside, this is your vertical controller. It just keeps the sign here. So k would be a negative 4, which means down 4. So it went left. I didn't write my 3 in here. Left 3 and down 4. Problem 2. What is the equation of the parent function f of x equals x squared? Not quite the right question. It should say after translation to the other graph, or the green graph, as you can see on my drawing. But the first thing you better be able to do, whether it says green graph or dotted graph or whatever, is you got to be able to identify which one of these is f of x equals x squared. And that's our parent quadratic. Remember the parabola, 0, 0, 1, 1, 2, 4. It's got those points on it. So that's your parent function, f of x equals x squared. And we're going to move the parent function to this new green function here. To do this, your best bet is just translate or look at where your vertex translates to. The lowest point of our parabola is the vertex, and it moved 1, 2, 3 right, and 1, 2, 3, 4 down. So this new function, this new f of x, has to go 3 to the left, so it's going to be, or 3 to the right rather, so x minus 3, and then down 4 would be minus 4 like it was up in this first one. Notice this one has to have the squared on it here because this is the quadratic. If you're going to write this in function notation, you'd say like, hey, new function g of x, you are the old function translated to the right 3 and down 4. So those two statements say the same exact thing, although this maybe instead of calling it f, I might call it f prime or something like that to say, hey, this is f, this new function is this one in green. Next problem. Now the next problem is different. Okay, notice there's still two graphs on it like this one, but completely different questions. This one we're talking about moving this graph over and down. Here we've got two distinct equations, and it's called a system, which means we're trying to find where these two equations share answers. Now normally we have to graph these to ourselves, but they've already graphed it for us. So here's all the solutions to the absolute value equation. That's the first one. The second equation is just a line. That's this purplish one, or this straight line right here. And so blue line are this second equation solutions. The other equation solution, where do they share? Well, they share right there. And so the answer to this system is, let's see, it's 1, 2, and it's down 1, 2, 3. So it's at 2, negative 3. Now this should be very checkable up here, buddy, so let's check it. It says y, in our case y is negative 3. Does that equal, question mark, the absolute value of x we think is a 2, 2 minus 3, absolute value minus 4. So I've just rewritten this equation, but I've replaced the y with what we think the y coordinate is, and I replaced the x with what we think the x is, and we'll just see if the left side equals the right side like it should. Left side we don't have to do any math on, it's just negative 3. Right hand side, let's see here, that's a negative 1. When we take the absolute value of it, it becomes positive 1 and then minus the 4 out here. and 1 minus 4 is negative 3. So yeah, this ordered pair just checked in the first equation. We'll mentally check it in the next equation. I'll put my x value of 2 in here for x. 2 times 2 is 4. And 4, take away 7, is negative 3, which should be the y value. It is. And so that point 2, negative 3 is certainly the solution to the system. All right, let's slide this all up here, and let's look at problem number 4. Use a graphing calculator to find the solution to the systems of the equations below. Round your answers to the nearest tenth if necessary. Well, it's kind of hard for me to show that on here. I can edit some stuff, but it takes too much time. So I'll just explain what you do. Okay, so this equation, you're just going to graph it on your calculator. We've talked about graphing these things before. Okay, we know how to find absolute values. I'll just graph this one, though, by hand here. This is the absolute value parent function, so it makes that V shape. It's going to be shifted right 2, turned upside down, reflected over the y-axis, and then it's going to go up 3. All right, so my vertex normally starts right here, but this one's going to go right 2. Then it's going to be flipped over the x-axis, but it's not going to change where it's at. And then it has to go up 3. 1, 2, 3. So I'm going to mark it over 2, up 3. And then it opens upside down. But I know the pattern it makes. It goes over 1, down 1, over 1, down 1. And when it goes over 2, it goes down 4. So it gives me a point right there. And symmetry tells me right there. So there is what your calculator would show you. Okay. Next, I'm going to graph this one right here in red. This is just a line. It has a slope of 1/4, then x, and plus b, but it doesn't have anything out there. Okay, so this one goes right through the origin with a slope of up 1 over 4. So up 1 over 4 puts me right about there. So that's what your calculator would do. Then you just have to do the old press the second and the button that says calc. And one of your choices is find intersection. Now this one's got 2 intersections. So you're going to just move your, follow the directions and try and find this point of intersection. Let's put them in pink. And that point of intersection. So I just ran this through my calculator. And my points of intersection, I found the one in the lower left side there. It comes out to be the ordered pair, and I had to round them. X is about negative 1.3. Yeah, I had my calculator calculate these, and x is negative 0.3. Now, it also turns out on my calculator, I can tell that this is a repeating 3, and so is that. And so I should indicate that, hey, I think that's a repeating 3 right there, because that's pretty accurate at that point. The other point that I found, because this thing intersects, they intersect each other twice, came out really nice. It came out to x is 4, and y is 1. Just like that. Okay, and again, you'll put that in your calculator, and you should be able to find those points in class to help you out. All right, problem 5 here. Here's a table showing all the ordered pairs for this equation and this equation. Okay, it's going to take you a little while to get your bearings around a problem like this. But here's this equation, y equals negative absolute value x minus 2 plus 2. And if you look over here, there's that equation. The second equation, a half x minus a half, that's the second column. And so in this column, we're showing all the x values, at least from negative 5 to 5. And in this column, the y values that come out of the first equation, and all the y values that come out of the second equation. So that's what's going on. Here's the table from my graphing calculator when I use this graph the system. What are the solutions to the system? Well, if I just look at it, remember, I'm trying to find where these two things intersect each other. So where do they have the same point or the same ordered pairs? Like this is -5, -5 for the first equation. It's -5, -3 ordered pair for the second equation. So that's not a shared solution. In fact, these things got to match. They got to have exactly the same y value at the same time they have the same x. So right here I can see there's a solution. Okay, when x is -1, the first equation goes through -1. And when x is -1, the second equation goes through that. And so that's a solution to the system. -1, -1. Now remember, they could cross twice. So you do want to check. There we go. There's another pair of solutions, or another solution. I apologize for my dog there. 3 gives me 1, and 3 gives me 1. And so my answer, or other ordered pair, is 3, 1. There's my solutions to that system. That's it for that page. Pretty simple. Okay? Nothing too hard on it. Let's flip it over and see if that causes us any more problems. See here, we got a solve by substitution problem and a solve by an elimination problem. We looked at several of these substitutions. Notice here, this one's already solved for y, and so I can substitute into the other equation. So I'll do that. -3x minus 2. Now I'm going to replace the y with 5x minus 7. And it says equals -12. And that equation I can solve pretty quick. Now be careful, you're going to have to distribute here. So I got -3x. Here comes that distribution. -2 times 5 is -10. X. -2 times -7 is plus 14. See, I've got a pair of like terms on this side. So we'll put those together. It's a total of -13x. And I'll take this 14 over, subtract it. -26, divide by -13. Looks like x is equal to a 2. Now don't forget, you got to go up and find y, but we got this beautiful equation right here. It says y is 5 times x minus 7. So y is 5 times 2 minus 7, or 10 minus 7, or 3. Solution for this guy, x is 2, y is 3. Now don't be shy about checking in this. If I put a 2 in for x, that's -6. If I put a 3 in for y, this would be -2 times 3. That'd be -6 also. And -6 minus -6 does equal, or -6 does equal -12. So I've checked it in both equations. I put the 2 into the first one, out came a 3. I plugged 2 and 3 into the second one, and it made it true. So I know it's a solution to both. To the right here now we have solved by elimination. So let's look at them, see how everything's lined up already for us. That's nice. I would certainly get rid of y's here because I just have to make this one into a -3. So I'll multiply him by -3 and add him to this equation, and my y's will be eliminated. So times -3 on both sides. I'm going to write it right below the other one that I'm going to add it to. Positive 21 x's, -3y's like I wanted, equals, and don't forget the other side, that is positive 57. I'm going to add these two right here, this one with this one now. We're going straight down. -2 and 21 is 19. The 3's add up to nothing. Let's see here. I've got to do -19 plus 57. So if I took away 20, that'd be 37. So it'd actually be 38. And I just divide by 19. Hey, x is 2. Now we got to go find our y value. I'm going to use equation 1 up here. Equation 1 is -7x plus y equals -19. I'm going to put in that 2 for x and figure out what y is. Negative 14 plus y equals negative 19. Add 14 to both sides. Y is equal to negative 5. So these two should intersect at that point. Now I am going to check it mentally in my other equation. Negative 2 times 2 would be a negative 4. 3 times negative 5 would be a negative 15. Negative 4 and negative 15 is negative 19. So it again checks in both equations. Alright, now our new problems. These are the ones we just practiced. So if you've had a hard time with these, this is maybe a good chance for you to get to them and figure them out. So here's my three equations. I'm going to number them 1, 2, and 3. We check to see if they're lined up. They are. And then we look at what would be easy to eliminate from all three equations. Well, 6, 5, and 3, their common multiple is like 30. I don't want to deal with that. This negative 1y here and this negative 1y, that means they're going to be pretty easy to eliminate, and it's pretty easy to eliminate the 5. So this is probably our best one. If we look at our z's, 3, 5, and 4, their least common multiple is 60, I think. Way too big. So we're going to eliminate y's, and that's our first choice we have to make. Okay? We're trying to eliminate y. And I should say first, because we got to eliminate something else later on. So let me think about how I'm going to do this. Right now, if I add equation 1 with equation 2, y will not disappear. But if I take equation 1 times a 5, it'll give me negative 5y, which would add to a 0 when combined with the positive 5y. So let's take equation 1 and multiply it times a 5. So I'm going to have 5 times, let's put him in pink, 6x minus y plus 3z equals negative 9. And I have to take him times the 5. Remember, keep your equation balanced. I'm going to switch to black now for my result. I've got 30x minus 5y plus 15z equals negative 45. I'm going to add this to equation 2, which is 5x plus 5y minus 5z equals 20. And let's get our new answer. See if we can get a nice color that will stand out for us. 35x, when I add 0 y's, 10 z's equals negative 45, and 20 is negative 25. So this would be like equation number 4, and we got to keep track of him because this new equation only has an x and a z in it. So now what we want to do is combine a different pair. I've already used 1 and 2 together, so I can use 1 with 3, or I could use 2 with 3. Those would be my other two combinations I could possibly make. And since 1 and 3 are so close with this y value, and I eliminated y first, so I got to keep eliminating y, I'm going to take equation 1 here times a negative 1, which will flip all of his signs, but then that positive y would cancel with the negative y. So I'm going to take negative 1 and multiply him times equation 1. And then we'll add on, or add him to, equation 3. So here we go. Negative 1 times, let's put him in pink again or something we can see, times 6x minus y plus 3z equals negative 9 times also negative 1. Put that in parentheses so it doesn't look like minus 1. Here comes the distribution. Negative 6x, positive y, flips all their signs. Negative 3z equals 9. Here comes equation 3, which should be set up now to eliminate the y's. And then our result, negative 3x, y's disappear, plus z equals 4. That's our equation number 5. I'm going to highlight him. He's our next important guy. So we now have taken our 3 equations with 3 things we didn't know in each of them and made it into 2 equations with only 2 things we don't know. And now we just have to use elimination with these 2 to eliminate either the x's or the z's. Clearly it's going to be easier to get rid of the z's, but we can do a little more work to this equation 4. In equation 4, everybody's divisible by 5. They either end in a 5 or a 0, so those are divisible by 5. So we're going to do that before we start to try and eliminate stuff. Because if we have a smaller equation, it'll just be easier to work with. There we go. And now I'm going to use this equation and get rid of my z's. This z is just a 1z. This is a 2z. So I'm going to take this times a 2, and more precisely a negative 2, so that it will cancel that positive 2. So here we go. I'll just take this equation here times negative 2. And that gives me positive 6x, negative 2z, negative 8. And it's ready to be added for our final equation. 13x equals negative 13. Divided by 13x is negative 1. So I now know what x is. I can use any of these equations that only have 2 variables in it. I could use this blue one with only x and z. See, x is no longer a variable. It's now negative 1. So I could use this one and figure out z. I could use this green one. I can use this pink one here. Let's see, the easiest one, it might be this pink one. So I'll just do the pink one. I'll go negative 3 times x, which is negative 1, plus z equals 4. And you can see this just multiplies to a 3. So it's 3 plus z equals 4. And then we subtract our 3. So z is 1. We now have 2 of our answers. We just need to find one more. I know z is 1, x is negative 1. This is where you go back up to an original equation with all 3 variables in it. Okay, let's use equation 1 here. By the way, I just noticed equation 2. We could have divided by 5 and made him really small. Let's go ahead and do that. And we'll use him. So I'm dividing by 5 here. I'll write my result right over here so I can use it. 5 divided by 5 is just x. Let's use a red marker here. Plus 5y divided by 5 is y. Minus 5z divided by 5 is negative z. And 20 divided by 5 is 4. And now we'll go ahead and figure out z is 1. So I'll put a negative and then my 1. X is negative 1, so I'll put a negative 1 there. I don't know y yet. That's pretty easy. This is y minus 2 equals 4. And so y is 6. There we go. We have a nice ordered triplet. Our answer is x is negative 1, y is 6, and z is 1. And we're done. On your test, you have more space than I provided here. You get a good half page to get that all in. Plenty of room to get that thing right. Take your time. Watch your signs. You'll be okay. All right. Number 8, graphing functions. All right, let's take a look and see what we got here. We got a function, f of x equals x squared, and it says graph this guy. Well, that's our parent function. In fact, they even give us a little table here for it. F of x is the x squared. So let's square each of these. That's 4. That's 1. 0 squared is 1. 1 squared is 1. 2 squared is 4. All righty. So let's go ahead and graph him. 0, 0, 1, 1, 2, 4. No surprises there. Let's draw him. Now, this next part, it says now we got a graph, still graph, g of x, and complete the table. So I could put negative 2 in here and calculate what the y value would be, and then plug in negative 1 and find the y value. That'd work great, but I can also already graph this guy. right? He is just this function right here I just graphed, but he goes right 3, and he goes down 4. So I'm just going to move each point. I'll start with my vertex. I'll just move him right 3, puts him at 3, and down 4, which puts him at -4. So there's my new vertex. Right, 3, down 4. It's going to follow the same pattern, so I could move each point by hand, or I can go 1, 1, and then over 2 and up 4. Just like that. And now, well, it looks like I still can't get my -2, but some of these points I can read to fill this thing out. Let's see here. When x is 1, right here, oh, the y value is 0. I'm right on the axis. Let's see here. When x is 2, I'm down here at -3. I don't have it when x is 0, okay? But I can still figure out these things either by substitution or just trying to mentally move my x and figure out my y. Let's just go ahead and do substitution. Let's find the g of 0, this one right here. 0 minus 3 squared minus 4 is -3 squared minus 4 is 9 minus 4 is 5. When x is -1, so let's put a -1 in there. G of -1 would be -1 minus 3 squared minus 4. -4 squared minus 4, which is 16 minus 4, which gives you 12. And then our last one, we'd have to put a 4 in here. This will be easy. 4 minus 3 is 1. 1 squared is 1, so it's 1 minus 4. -3. This would give us, I mean, we could find these points by extending this and graphing it like this, but I think find the ones you can from translation and then just do substitution to find the other points. Let's see here. Ooh, identify the x-intercepts and y-intercepts if they exist. It should say in reference to this one right here. This is asking for the x and y-intercepts of this purple line. Now, I can see the x-intercepts. Here they are. X-intercept. That one is at 2, 3, 4, 5, 0. So that's one of my answers. And there's another intercept right there where it crosses. That's at 1, 0. Notice, because these are x-intercepts, the y value has to be 0. Otherwise, it wouldn't be on the x-axis. So x-intercepts, we got one at 1, 0. We also have one at 5, 0. And y-intercepts, where does it cross the y-axis? So that's actually in our table over here. When x was 0, the y value is 5. So that puts us on the y-axis. In fact, we could graph that point. This is where this graph is going to go to. And so we can answer for the y-intercept. It is at when x is 0, y is 5. See, number 10, write the equation. So right here, we want the parent function x squared translated right 5. So let's start building this thing. F of x, let's translate him. To move him right 5, we have to go x minus 5. Vertically stretch by a factor of 3. Vertically stretching, that goes in front of the function. So there's our 3 out front. Reflected over the x-axis, our reflections come next. Over the x-axis means we have to have the negative out in front, so it flips the whole thing upside down. So we get a minus sign in front of this thing. And then lastly, we have to go down 3. That's the easy one, so down 3 at the end as well. So there we go. This one goes right 5. Gets stretched vertically by a factor of 3. Remember, inside does horizontal, outside does vertical. reflected over the x-axis, so it's flipped upside down and then down 3 units. Looks good. Number 11 is a classic one from SATs and from stuff we talked about in class. How many solutions does this system have? And they give you 2 equations, and they aren't asking you to solve it. Now, you could solve it and find out, hey, does it have a single solution across, or are these 2 lines the same line? But really, what you want to do, because these are lines, is just get them into this y equals mx plus b form. The first one already is. The second one, we've done this before. It's 2 steps. Subtract 6x, the x term from both sides. Divide by -2. Okay, this is chapter 1 stuff that we did. X minus 4. So there's our other equation in slope-intercept form. And all we have to do is look at their slopes. I can see they're both 3. I can also tell that they are different lines. Okay, so they're different lines, but they have the same slope. So without a doubt, I'm guaranteed these lines are parallel, and therefore they have no solutions. The solution is not 0. That's just how many they have. None. All right, so here is that full graph or full paper. Hopefully it's all recorded.